Hey y'all, welcome to the second video in a series dedicated to algorithm design and analysis. Today, we're going to dive into the merge sort algorithm, so let's get started. To understand merge sort, you need to understand recursion, and just searching recursion may take you down a never-ending and frustrating path. Keeping it simple, recursion is a technique where a function calls itself as a step repeatedly until a break condition is met. Then the result of the function is bubbled back up the stack. Divide and conquer is the name of the game. Take a look at this array of 8 elements. We'll divide it in half between the 1 and the 8. Next, we take the two smaller arrays and apply the same method of splitting them in half to create even smaller arrays. And we will keep doing this until the subarrays have only one element each. This is the divide step in the merge sort. Once we've broken down the array into arrays of one element each, we start to bubble the results back up in the conquer step. As the results start to bubble back up, the two subarrays will be merged together in sorted order, and this will continue until we get the one fully sorted array. We take an unsorted array and we break it down into arrays of one element each. Then, as we put them back together, we make sure that we build them by sorting the elements. That way we end up with a fully sorted array. Let's look to implement this in JavaScript. And we'll start with an unsorted array that holds the same numbers as before, 6, 5, 3, 1, 8, 7, 2, and 4. Now let's stub out our merge sort. It won't return anything yet, but when we're done, it'll take in as an argument an unsorted array of numbers and return a sorted array of numbers. If we were to console log the return of our merge sort function, we would expect to see our array in sorted order of 1, 2, 3, 4, 5, 6, 7, and 8. Let's get back to writing our merge sort function. The first step of a merge sort is the divide. So we'll take our unsorted array and divide it into two subarrays, arrays A and B. Array A is a slice from the 0 index to about halfway through the unsorted array. We calculate this by flooring the result of the unsorted array's length divided by 2. Our array B is a slice from about the halfway point of the unsorted array until the array's end. After the divide step, we must execute the conquer step. Our conquer function will take in the two subarrays, arrays A and B, and it'll eventually return a sorted array of numbers. We'll call that array C. Our conquer looks to merge arrays A and B into sorted order. It'll do this with a few steps. The first of which is that while arrays A and B both have elements in them, we'll compare the first elements in the arrays. If array A's first element is less than B's, we'll remove it from array A and add it to array C using a shift and a push. And if B's first element is less than A's, we'll also shift and push it into array C. If either array A or array B run out of elements, we'll just push in the remainder of their values into array C, starting with array A, then moving to array B. Now, let's have our merge sort function take the two arrays and merge them back together with the conquer function. Remember that we need to recursively break down our unsorted array into arrays of one element each before we can put them back together. So we'll pass into our conquer function the results of arrays A and B being passed into the merge sort function. As it stands now, this function will run forever, or until your computer runs out of memory. That's because we keep trying to call the merge sort, and we keep trying to split the array to halves. So we'll do a check to see if the array has only one element in it. And if it does, we don't need to split it in half or call the merge sort function. We can just return the array of one element. We're pretty much done here. So let's take the code and run it. In terminal, I'll just type in node index.js and click enter. The result is the sorted array of 1, 2, 3, 4, 5, 6, 7, and 8. Something I didn't cover in the last video was the time complexity for the algorithm. And for merge sort, it runs at n log n. That's because the input can only be divided in half log n times. And we iterate over n items log n times, hence n log n. Anyway, that's all for today. Remember to give this video a thumbs up and share it if you liked it. And if you want to see more videos like this, be sure to subscribe. My name is Michael Slotty. You can find me anywhere on the web from Dev2 to GitHub to Twitter. So, until next time, see ya.